So welcome back. I trust you found the intake interviews activity interesting, informative, useful. So it'd be an interesting discussion on my table. So hopefully that was useful for everybody. We pick up with the last session of the morning between now and lunch. And the theme for today, this session, is mapping researcher needs to DRI skills and infrastructure. And we have a load of new faces on the panel here who have yet to grace the stage. And I believe we've also got Kirsty online. So we'll start off with brief introductions, starting off with Emma.
Hi everyone, I'm Emma Barnes. I'm Head of Research and Faculty IT at the University of York. So we support academics, both with teaching and their research needs, if it's from a computational support point of view.
Thank you. Peter.
I'm Peter. I'm one of the last batch of the EPSRC RSC Fellows. So although I'm an RSC, I'm embedded within a group and I have my own agenda. So I work on software sustainability within the plasma science community. So I try to do lots of quite focused projects on sustainability across the entire plasma community, like both my group, but also like internationally. So I kind of go to people and try and do projects for them rather than have a more usual model, perhaps, of people coming to me to do things.
Thank you. David.
I'm David Henty. I'm in charge of education and training at EPCC up in Edinburgh. I'm kind of institutionalised. I've been there for about 30 years. I think looking back, I've probably been an RSC of some form for about the past 30 years. And specifically, I do a lot of help desk user queries for the national services, training. We run a training programme for the Arch 2 service. And we've also been running an MSc in HPC, and HPC with data science since 2001. And I get involved in various technical projects, maybe not at a deep level now, but more to sort of a higher advisory level.
Thank you. Michael.
I'm Michael Holliday. I'm Head of Research IT Infrastructure at ECL, so I look after all of our HPC, all of our storage, backup, archive, every bit of hardware that we have in our data centre. I sort of have to keep running in some form or another.
Thank you. And I believe we've got Kirsty online.
Yep, you have indeed. Hi there, I'm Kirsty Lingstadt. So we very much support researchers from the library perspective around about research data management planning, and some of their repository needs.
Thank you. So we have a diverse panel spanning the wide range of different interests in the room. And the theme of this session is how do we make sure that we're putting the right people in touch with the right technologies, the right infrastructure. Hence the broad panel here. And also thinking about future needs. How do we identify the future needs of our researchers, of the communities that we're serving? So I guess the opening question is going to be, when you're thinking about your interaction with researchers, how do you go about assessing their needs and what might be the right infrastructure for them? So Emma, we'll start with you.
Sure. So I think the previous activity, I can't think today, we had is sort of similar to the approach we tend to take. One of the biggest things we have to do is talk to the academics, understand the type of research that they're doing. Obviously, we're not ever going to be experts in that particular area, but then start to distill it into what can we provide. So my team's actually based in IT services, so I'm aware of a lot of facilities, other parts that are offered to academics, but they may not know about it. So, for example, they may think they need a computer, but actually a virtual machine will suffice. They may think they can run this on their desktop, even though it's, their desktop's 10 years old, but actually you could probably pop that into the cloud now. And it's all that sort of the knowledge from our side is kind of understanding what technological forest we have available to people and being able to sort of distill that and marry the two between the research and the sort of infrastructure. In terms of trying to see what's happening in the future, that's one of the more difficult ones. I've been part of 2 procurements for our HPC now at York, and we certainly got the GPU part of Viking 1, which is our, the names of our facilities, wrong. We did actually go around and talk to lots of academics, and we ended up with 8 V100s, and then obviously over the past 5 years GPU use has just spiraled completely. We've obviously, with our new procurement, we've changed that. We've now got a combination of A40s and H100s and try to bolster that sort of area for academics. So you're not always going to get it right. There are things, again, you can do in the meantime, whether that's using cloud resource or trying to push people to facilities such as BEAD and things like that. So it's not completely the worst situation, but it can be quite difficult. But I think part of it is just trying to make sure you have a good communication with academics. You're constantly trying to turn up to meetings, whether I'm invited or not. Seminars.
You're always welcome.
Thank you. And just sort of show yourself as to be part of, you know, I always say I'm 1 foot in IT and 1 foot in research. That's kind of how I am. That's how I feel like I have to be, because you know, I want to make sure that what IT services are doing is actually beneficial for teaching and research, which is the core business of the university, and we should be providing the facilities to help that to happen.
Thank you. Peter, so a different perspective?
Yeah, so on a couple of things. One of the things is that I normally talk to PhD students more, because they're the ones doing the work in some sense. And so I'm looking out not just what does the researcher need, but what does the project need, right? Because often the bit of software might outlive the PhD student that's working on it. Outlive is maybe the wrong word.
The project?
Yeah, the project's going to last a long time. So I'm looking out for, okay, what does this project need, not just as well as what is best for this particular researcher. What does this researcher need? Do they need training? Can I signpost them to particular things? And because I'm working within a particular community that I've come out of, you know, I've done a PhD and a postdoc in plasma, so I can talk the language more, you know, so I can connect on the science level, and that allows me also to kind of point out the software infrastructure that they might need. So I was talking about the hardware that she can connect them with. I might know of other software packages that do some or all of what they want to do. So they don't need to reinvent the wheel. Maybe there's something out there already that I can connect them with. And then that means that they don't need to learn how to do something in depth as much. They can use this other thing, and also bolsters the community of that other thing and helps that grow as well. So that's one of the things that I'm looking out for in those sort of initial interviews. Are there things that I can connect them to at the software level, and then signpost to people like Emma, and that if they need HPC, is there somebody in that space that I can bring them to?
So talking of HPC goes to David.
Yeah, so working in an HPC centre, we often don't have a control over what the hardware is or what the users are, because the hardware has been procured and the user groups have been decided. But on that going forward, I think the big challenge in the UK is GPUs coming along, being almost universal. And I think the US went through that transition maybe a decade ago. But we're a bit, I know certain communities, I know that, you know, STFC communities have had big GPU resources, but, you know, the bulk of big computing seems to be going towards GPUs. And that's going to be a training issue. Are people ready for that, training people up? So that's looking forward. Sort of on the intake side, because we run an MSc, we see the skills that students are coming in with. And my concern there is there's a widening gap between the skills that student comes in with and what they need even to get started on, even a mid-range cluster. And you can do two things. I mean, I'm old, so I'm a bit of a Luddite, but you can do things that aren't students today, you know, awful, but that's not, you know, we've decided the education system they go through. It's, you know, it's not they've done what they've done. Or we recognise it. So for the first time now on MSc, we're actually going to teach a course on compiled languages. Not say, well, they'll know C, we'll teach them C++, you know, because we used to think, well, they know Python. You look at a Python program, it looks a bit like a C program, but actually the culture people are learning Python is, it's completely different beast from writing. So we're, you know, that's, again, I think that we have to recognise there is that gap. that many students aren't coming in with what we think of as being an old person basic skills, so we need to teach it and also make them see it's valuable as well. That's the other thing. You know, why should I learn this when I can run a Python script to do some AI thing on a big HPC machine and make lots of money writing that ChatGPT? But I think that is a big issue. Just at the time that the technology is moving to the next level, it's going to require even deeper skills. I think, you know, from the intake is moving away from that. And I think that's potentially a concern. And we're losing, I mean, it's just, again, my age. Someone talks about learning to program a BBC Micro. We seem to be losing that sort of, the thing which fed the first sort of generation, that sort of hobbyist programmer type approach doesn't seem to be so prevalent now.
Just to pick up one point there about the skills gap with your MSc, are you seeing that because people are coming from a broader range of backgrounds rather than the traditional kind of route into the MScs? Is that where there's the skills gap because they're coming from a wider range?
Possibly, but also I think, you know, people who did a physics, chemistry, maths degree used to do a bit of, it was, you know, maybe they would do something like Fortran, then maybe C, and then Java, but they still felt like, now that's all moving to Python and Python notebooks. So people are learning incredibly sophisticated techniques in numerical analysis and engineering and such like, but the environment they're doing it is within Python notebooks, and that doesn't prepare them, I think, for what the first ladder is on the more HPC side.
Okay, thank you. So, more hardware side of things, Michael?
So I guess from our side point of view, we have to design our systems, but obviously they take time to exist, and it can be 2 or 3 years. We have at least one system that is, so in the time it took us to get it running, they doesn't match any of the requirements that they wanted to do it. So we are still working on trying to keep past up with all of that. But obviously, because UCL is so big, we have to talk to every department and we have to take in all of their requirements, which can vary from, obviously, our computer science department, who pretty much would tell us they know everything, and to other departments who basically never used it. But then it's also working about how that data is stored, where it's stored, trying to explain to various people that storing that data on a NAS box under the desk is not the way to be doing this because you will lose it eventually. And it's also just trying to explain all of our central services and trying to explain why they cost what they cost and why they're bigger and more expensive. And yes, there are efficiencies, but they're always going to be more expensive than maybe a desktop underneath them.
So are the user expectations realistic?
It varies from department to department. Some have very realistic understanding of what they can and can't do. Some people, as I was describing to one of our data stewards, will turn up with a NAS box and go, here's a NAS box, go make it work in exactly the same way on your system in the next 2 days. At which point there's a lot of trying to reduce the expectation of how fast we can actually make that happen and explaining that things do change in a central system.
So in terms of anticipating future needs, how do you get that message to users about this lead time in actually getting the hardware up and running?
So it's very much, it's a lot of having, we have a good team of data stewards and RSCs and our HPC support guys who can go out and work with our users and trying to explain that expectation. We have also our leadership teams who inevitably want everything now, but they are getting them on side and getting them to be able to go out as the vice provost and the CIO and being able to actually explain how long these things can take. And that a new cluster is not going to appear on somebody's doorstep in 2 days' time because things take that time to get them in and running and tested.
Thank you. Kirsty, how are things different in your world?
I suppose we're focusing much more on the data that the researchers are working with, and kind of picking up from the last speaker, thinking much more around about, you know, how they're going to store and manage that data, and how they're going to work with that data. What are they going to do through the life cycle of their research so that they've got sensibly organised research data that they're perhaps depositing in a data centre at the end of their sort of research process. So we're very much focusing on that research data management piece, that really active curation throughout the entire sort of life cycle that they're going to be going through from starting the project to finishing the project and fulfilling those kind of funder requirements. So that's where we're really actively engaging with them. We're also very much encouraging them not to just, you know, store stuff up on their desktop without putting any structures in place. So that's where we're really, really focused on. And then also looking a little bit at some of the research infrastructure across the university where they might need to interact with for a variety of purposes. But it's very much focusing on what to do with the research data, how to do it, and how to actively manage it. And of course, they need the research infrastructure that you've all been talking about to do that in. So that's where we come in.
So we're talking about who you're talking to. Is it primarily the academic PIs, or is it the, I think as Peter put it, the PhDs that actually do the work? Who are you talking to?
We're talking to a mix of people, and it depends on the project, it depends on the academic. Sometimes we're talking with the PI, sometimes we'll be talking to the sort of PhD. Sometimes people will be coming to us well in advance and having a bit of a chat to think about what they need to do. Sometimes they've already started and they're going, oh, I know I wrote this plan, but now I'm finding it's not quite working and we need to untangle things. So at different stages and quite often with different people on the research project.
Okay, thank you. So obviously you have different user groups that you're working with. The question now is, do you find that within the users that you're working with, there's a particularly vocal subgroup that kind of demands all your attention? And who might that be? And how do you deal with the less vocal people? How do you make sure they don't get ignored? So Emma, must be a big issue for IT services.
Yes, yeah. So I think we try to offer as many places to get in contact with us as possible. So we've obviously got working groups and procurement groups where we tend to invite kind of academics to be part of that. That's been really helpful in the development of our clusters, for example. Again, another problem with that though is you tend to get the more science focused academics, and we still are trying to kind of say, okay, you might not be actively using our HPC now, but it could be something you're interested in. Another piece is we have things like Research Coding Club, which Peter knows a lot about, and we also have some Slack groups, we have our RSEs. So I don't think there's any one particular way to try and contact people. We tend to try to get into departments as well, so if it's an all staff briefing, I try to, can I give a talk on research IT and what that means to people. Also, if there's new postgraduates, no matter what subject matter, I'll try and give a talk to them when they first hit the university, and that's something we have to do all the time. So it's not something you do once and then leave it. You literally have to do it all the time because there's new students coming through, there's new staff coming through, and I think we're slowly getting there in some of the areas. I've fortunately hired a Phil in my team who's language and linguistics oriented, and that's been really good in the sense that before most of the people in my team were physicists or CS people, so that's actually created a new avenue and a bunch of new contacts where we've been able to talk to students and academics in that area, and I think that's something we want to do more of going forwards.
Okay, thank you. Peter, vocal versus non-vocal, how do you make sure people don't get left out?
Yeah, I find this a big challenge. So the people that I talk to most are like user developers, people that are developing the code and using it, and so they tend to be much more engaged with knowing that they need to do something, right? Knowing that there's a problem and knowing that they should do something about it, and so and I'm interested in helping those people, but I'm also really interested in helping the people that don't realise that there's a problem with their code or their project, and so. Yeah, going around and talking to like every possible venue that I can, I find really useful. So I try to get in at the PhD induction. Again, the PhD students, they're doing the work, but they tend to also be more cognizant that this could be better, whereas perhaps. The further you go in your career, you might be a bit more entrenched in your views, perhaps.
You develop blind spots.
Yeah. Or, this is how it's done and it works, so it's fine. Right?
Good enough.
Yeah. So getting people early, I find really useful. And then also getting people to talk to their peers and, that after I've helped somebody, getting them to talk to their peers who don't realise that there are resources available. You know, they might realise there's a problem, but they don't realise that that's something that can be done. So that's useful to encourage people to kind of go out and spread the word about these things, because then you'll get the people that don't turn up to the training events, for instance.
So David, with all your skills and help desk, how do you reach the non-vocal ones, the quiet ones?
It's different. So I think I wouldn't go as far as advocating what they do in, say, diving, where you have 8 judges and you lop off the highest and the lowest scores being outliers. But when we run courses, we always take feedback, and if we have a new member start delivering a course, they're often shocked if they get negative feedback. Like, well, you taught 25 people, and one person has made a negative comment. That's actually fine. So you have to be. So that is a real issue. Yeah, vocal groups. But I think what you're saying is very interesting, because just because people are happy with what's going on doesn't mean that things are good for them. People are very good at coping. But for example, we had this. You know, in the old days when I was, we ran a simulation. I/O was cheap. You dumped and then you do all your analysis offline. And then I/O gets harder, slower. You're running on more processors. But people were coping. Well, I mean, the history of the national systems, when Hector was running, people were still coping. But you realise what they were doing is they were writing less and less and less. But then you get to a stage where you've got to write once at the end. And so we seem to have this sudden issue when we went to Archer that suddenly everyone had I/O problems, but it had been building up for a long time, and people had just been living with it. Now, that's just what you do. Just write less often, do the analysis in line, but you have to write out once at the end. And then it was a huge. That's when I only first learned anything about parallel I/O, which our users were having these issues. So it is very, very difficult. And I think, it's easy to think that just because people are coping that the resources are adequate, and often they're not. Often they're just living with what they've got, and that can. But we do get a lot of sort of, subliminal stuff. You read the runes a lot more with the help desk. So we've reorganised our team now that we're much more. There's a set of people, smaller set of people who work on queries for a set. We used to distribute user queries across the whole department. 20, 30, 40 people would get based on their on their skills. Now we have a central group, and we meet twice a week, and that allows you much easier to identify trends. You'll say, and people will say, well, we've had an awful lot of queries about this. And that's on an operational level. I know that's not for planning. That's really valuable. You can say, look, there's something going on here. There's an awful lot of people have had issues with CPUK over a couple of weeks. That's not what's going on, and you realise it's an I/O issue or something like that. So that's really useful. But that was a change we made to allow that to happen. So that has been very. One thing I would say, kind of going back to in terms of forward planning, when I get a user query and my job crashes, what users seem worst at doing is all they know is that their job previously ran. So it ran within the time limit. It used less memory than was available, and it used less disk space than was available. When you actually ask them, how long did it run for? How much disk space did it use? People don't know, even with an order of magnitude, a megabyte, a terabyte, a gigabyte, a petabyte, don't know. So, but I think that's, if you're going forward planning, saying we need these resources in the future, it's really worth sitting down and just, within a ballpark, what are your needs? Because memory's really expensive. If you say, and we need loads of memories, they're going to buy a system with huge amounts of memory, and then you don't use it, that's a huge waste. So it is really important to have an idea of what you really need. Yeah.
Cool. Michael, how do you get to know what the needs of the less vocal people in your communities?
So I'd say certainly ECL is extremely difficult, given how big we are. We have so many departments. Trying to find them at times is extremely difficult. But a lot of it, we have a community team and an education team in advanced research computing, so they're often doing training, running drop-in sessions. They're trying to make us as visible and as easily findable as possible, and making us as happy for academics to come and talk to us whenever they have a problem. Particularly ARC, now that we're both professional services and an academic department, we kind of have a less political problem in that we're not central IT anymore. So therefore, a lot of academics are more willing to talk to us in general.
They're more willing or less willing?
More willing, because we're not central IT. Oddly enough, we don't have the reputation of our RSD colleagues to be some of our researchers. But obviously that means that we can actually go and talk to them, and they're more willing to accept that we actually know what we're talking about, and but also a lot of it is knowing where all the departments are that are not using our HPC systems, not using our storage, and trying to work out why they're not using it.
So are you actually trying to identify the groups or departments that are not using your facilities and actually reaching out to them somehow?
Yeah, so we have data stewards and various other people who are all trying to reach out. Ironically, at the moment, we also have the provost who is panicking that the data is not on our central storage and is under people's desks. So there is a pressure coming from above and from us trying to go out and find all this data, find all the compute services that are not very well managed, but also try and find all the ones that are not using it where they probably could do, and actually trying to work with them and actually train them and give them the skills, as sort of said, from the moment they arrive at UCL, not just 10 years later when something comes up.
Cool, thank you. Kirsty?
Very sort of similar approach as many of the others have kind of noted, that getting out and about and talking to as many people as possible. And again, we run kind of training sessions at regular intervals and different locations and spaces in order to encourage, and both kind of online and in person. So kind of real mixed offer to reach as many people as possible. And also then linking in with different areas in the university to highlight and make sure we're all aware of what each other offers so that we can cross-promote that. And again, also having some sort of self-service information and content available to help support people. So real mixed approach, and then kind of also utilising the university's meeting and governance structures to kind of highlight the work that can be done and where people can find us, and just kind of raise awareness through that and get others to share that information.
So a very active approach.
Quite an active approach, or as active as we can be, and with the sort of size team we've got. And again, it is really hard if someone isn't vocal and doesn't say anything, and if you don't get any pointers or hints, it is possible to miss people off. But what we're trying to do is make sure as many people have the information as possible.
Okay. So I'm aware of the time, and I know we started a little late, so we have lots of questions I'd like to ask, but we might have to be a little bit more selective in the questions. And I want to give chance for the audience to ask their questions too. So we've been thinking about identifying the different groups within our users and trying to map their needs to our infrastructure, whether it's hardware or software or other things. Does there come a point when you say what you're asking for is outside of my ability to deliver? It's outside of the scope for us to fund. How do you decide what's outside of scope, and who decides? Who are you accountable to when you make those decisions? Say to a user, no, you can't have that, we can't deliver. At saying no to somebody, how do you decide that?
I mean, it's not pleasant, but you do have to do that sometimes. And I think that, say if someone came in and said they want their own cluster, we'd say no to that now and say, no, we've just built a new cluster. And then try and understand, why do you not want to use our cluster? What are the issues there which are preventing you from moving to that? And maybe it's something like training, or there's the application's not on there. I've had people say, we can't use that because it doesn't have the application. I was like, well, we can put the application on, it's fine. We can do that for you. So sometimes there's a bit of kind of people don't fully understand what is available, what people can do. But then there are some situations where what they're asking for is just insecure, and it could be, a security issue for the university, and we do try to, a security issue for them and their data, and universities are a target now, so we do tend to try and work and look at ways in which can we host this off-site, can we do something else, but also there's a capacity issue with the team. The more complex a problem you're asking for, the more time you need a person in your team to be able to devote to that, and there could be quite a big weight for that. We're not a huge team, so it's not nice to say no, but sometimes you do have to. And I think as long as you're showing you've had a proper conversation, you've looked at what options there are, and you're trying to work with that person, I think people are generally receptive to that. Nobody likes being told no, I'm included in that, but if we're a little bit more receptive to that than just an out and outright no, you can't have that. I mean, I would get annoyed by that and ask why. So.
Other people, other views, how you want to respond to saying no and deciding what's out of scope?
I set expectations up front because I've got this quite easy because I've decided the scope already, right? I'm doing software sustainability,
Yeah.
so I don't do features, right? I don't add new physics to codes. So, but I'm going to people and saying, I would like to do work for you for free. I will do this and no more. And people are really receptive to that. You know, some people still, oh, what about, you know, this thing? I'm like, well, that's probably a bit too much work, but maybe what if we did this instead? Can we scale that back? So you know, there's a bit of back and forth, but it's sort of easy for me because I've already laid it out. But then I can say, okay, you want this bigger thing, why don't you talk to these other people? So I can signpost them.
Signposting. Okay.
Not fob them off, but say, go talk to these other people. They might be able to help you. Or maybe that's something that you need to build into a grant application. I could help you write that grant application. So I don't say no. I kind of redirect and signpost to something else. But I've already laid out, you know, like, I'm not going to do this ahead. This is what I will do.
David, there must be times when you have to say no to users.
Yeah, I mean, the systems are set up quite rigidly, but there's quite a latency to change. The classic one you get is people want to run really, really long jobs, and we can't support that. But often that's a sign of an underlying problem. That's actually they've just, you know, you have to say, well, why are you running for 48, 64%? Can't you run for a day and checkpoint? And you say to them, look, going forward, there's going to be the chance of there being a system software. You know, running for that length of time is dangerous. You know, you could lose everything due to a glitch. So often it's a sign of, you know, people often say, you know, I run this job on my laptop. I want to spew out vast numbers of small jobs on your system, and often that will just kill the system with the way they're doing it. But you can re-engineer the software, just put in a better harness or something. But often it's a sign of something which is, you know, that first request of something where you have to say no is actually a sign that they've hit a brick wall, and you maybe need to do something more.
So when you have to say no to a user, is then a follow-up conversation to try and educate them or help them in some way? It's not just no and go away.
Yeah, I mean, I would normally ask, you know, take a step back and say, well, you know, you say you need to run 96-hour jobs, you know, but what you're actually trying to do? What are you trying to do? And then you can often find out, you know, that maybe if you gave them more disk space, I don't know, but but I do think it's often a sign of them hitting a wall, which is when they need to do something more. They can't just keep running for longer or asking for more memory or using more disk space. They need to change something.
They need to change
in the way they're tackling the problem.
So Michael, with the hardware side, there must be lots of cases where we have to say no to people. How do you handle that?
So a lot of it is being very clear and explaining why you can't do this, or just explaining how better to do it than the way they're currently doing it. It may be a case of just being clear about roadmaps, about when you're going to be able to provide the service they want, and working with them to find a temporary solution. So particularly one of the ones we have at the moment is various people want to store their sensitive data on various different systems, and they don't particularly like our data safe haven because it puts up barriers to them. And we are working on trusted research environments, but we don't have them yet. But trying to explain that to them and working with them about when we might have them, getting our security colleagues to actually be able to work with them and look at whether it's actually sensitive data or not. Working out if they can anonymize it, just actually being upfront and clear about it rather than just saying no. There may be cases where it's a case of no, you can't keep doing what you're doing, even if you've been doing it for 10 years. But being absolutely clear as to why they can't do it and not just saying no and not looking like the sort of bad guy having to be the person telling them that they can't do their research the way they want to do it.
So security and that kind of thing is the major issue? Security
and just generally the way that a lot of their systems are not designed to do what they were doing, or they're particularly a lot of the time in UCL it's a historical thing in that various departments have been allowed to just do things the way they want to do them, and trying to get them to change from that it's usually sort of a saying no, but saying no without saying no kind of problem.
So do they get pushback from then? How do you have to defend your decision? Do you have to point to some higher authority, or how do you point to a policy, or how do you get around that?
So a lot of it is pointing them to the right people. So we have information security governance group who are the ultimate authority if there is a security issue, but we also have our CIO leadership teams, our directors, our provosts who have particular policies and views on things. A lot of it is sometimes getting the deans and the heads of departments on board and trying to get them to go and talk to particular users. We also have our faculty IT colleagues who are very good at trying to come up with plans on how to solve short-term problems while we actually sort out longer-term problems as well.
Cool. Kirsty, are there ever times when you have to say no to users, and how do you do that?
Yes, we do. And I think, again, it's that being really clear about the offer that you have and what you can do. So we won't write your research data management plan for you, but we will train you on how to do it, and we will help and advise, and we'll also review your plan once you've written it, but you do actually need to write it. So it's about being really clear and kind of, again, highlighting and signposting where additional help and support can come. And then again, quite often we get kind of asked around about sort of skills and sort of training needs around about that. And again, we've got a sort of clear offer. We will sometimes develop new areas and kind of new digital skills if there's a real need. And again, we do that sort of in partnership with our stakeholders, but we're usually very clear and articulate what our offer is and what we can do. And then we sort of will refer and point back to that if we get people who want more and kind of are asking for things that we can't really support.
Okay, thank you. So I'm sure there's much more we could talk about, but I don't want to monopolise the conversation. I want to hear questions and comments from the floor. So over to you. What question? We have the panel. We have a broad panel of ideas and expertise. Alan, you can't ask. Come on, stand up.
I'll ask a question. So, I mean, it's picking up on the kind of the saying no question, and we're talking a lot about the kind of relationships with researchers here. I guess the sort of your kind of professional support network, whatever it may be, sort of, who is it important for you that basically you rely on to like have your back, right? In having the sort of authority in those conversations. Who are those that support network that you rely on within wherever it is?
Anyone want to chip in with that one?
I've got a few people, I would say. I've obviously got my boss, my boss's boss, who tend to have my back, but actually there are other academics who, someone wants to do something weird and strange on Viking, then we'll actually put that to our management committee, and then it becomes not just a decision by me, it actually becomes a decision by committee, which I know people get angry by that, but actually it works nice that I'm not the enemy all the time, and that's something that can be discussed. So I found that it's not just kind of the hierarchy of my line management, but there are actually other people around the university who have also supported my decisions and plans.
Others?
So from the help desk side, we used to rely, when we onboard, we're very keen for junior staff to get involved in it because it gives them a good exposure and they learn. Answering queries is a great way to learn. But pre-COVID, when EPC was also smaller, if they wanted help, they could just ask at coffee or lunch. They could bump into somebody. I think post-COVID, with much more remote working, we realised that wasn't working. That's why we reorganised into this team, so we can quite happy to give a challenging query to a new member of staff, saying, look, if you have any problem, ask up. We have a chat board for all of us that are working on. We have regular meetings, and if something gets tried, hand it on to me. I'll deal with it. So, but it is really, I've always been lucky enough to work in an organisation, even when I was a researcher briefly 4 or 5 years, where there were lots of people, and I would just go and ask people. So I always felt people had my back. I think it must be very difficult if you're out on your own. But if it happens on the help desk, someone said, I really don't think we can do that, and I'm saying, yeah. And the tendency of junior staff is to do too much, to really kind of say, look, it's not, it's not. You're going to spend more time on this than the user is, and hand it up. I'll say no. I'll deal with that kind of thing. I get overpaid to do that compared to you. So I think that, but it is really important to have people. But you need to allow people to take, otherwise no one learns. And it's like surgeons. I must be, how do you're doing your first operation as a surgeon, maybe there's no backup point. But we have that ability that, because we're offline, you can say, look, I don't have to answer this now. Do I cut the left aorta or the right aorta? I don't know. But we can take a step back and ask somebody. But it's difficult onboarding new people. But I think that's a critical thing. Feeling somebody has your back, trust you enough to do it, but really clear. As soon as you have an issue, come and chat to me. We might solve it. If not, just pass it up and someone else will do it.
So it's great that you give your junior staff the support been you,
Yeah.
who's got your back?
I feel, yes, I've always felt I've had support. I'm lucky that the people, my direct people I work with, or for what I've worked with for many years, that's the way it's been. We're the glass ceiling of pale male. Anyway, but whatever it is. But I think, yes, I do feel that's not, I think that's through personal relations, really, which is, again, fortunate.
Yeah. Does anybody else want to chip in on that, or have we got more questions from the floor? Anybody else want to chip in? Okay. Another question from the floor. If you could stand up, please.
Hi, I'm Simon Burbage. We've got lots of new users coming into our community doing AI on GPUs and things. The question I have for the panel is, how do you value what they need against your existing users, and the balance between how much resources, how many GPUs should you buy against CPUs, and how do you say no, maybe 50% to them?
So balancing the needs of new users and new requirements as existing users. Okay. Who wants to go that? Michael, maybe hardware would be a start place that.
I guess to some degree we get our provosts and vice provosts are determined to buy more GPUs by the barrel load at the moment. So we are kind of not really getting a choice in that matter, but we are trying to keep all of our current clusters, all our CPU systems running and supporting all of our users, but we're also looking at the future and expanding them, adding new GPUs, and actually trying to make those services work in a more flexible way. That means we can actually rebalance hardware between different services and systems, so then we can support whichever users happen to need things at that particular time, and then get more efficiency out of that hardware as well.
Does it put a pressure on your team? Do you need to grow your team to cope with the new needs?
Certainly we are trying to hire more people. That's always more hardware, and it creates new challenges in that every vendor, every different system needs different people looking after it.
So do you have to restrict the number of vendors and the variety of hardware to make it more manageable for yourselves?
We do.
Is that the saying no to the users sometimes, or changing the answer?
We do try to have standardized hardware so that we try and sell things specifically to people. So if people want to buy nodes on our clusters, they have a list of nodes they can buy, and that means we can guarantee that they can be maintained with everything else. Obviously, from time to time, we do get different users who want specific things, and there is a policies and set of rules about when and if we ever say yes to these things, and we also have to be a little bit careful, because if we say no, it quite often turns up in somebody else's rack somewhere else, and
those pesky academics will find a way around you. Okay, thank you. Anybody else got comments on the dealing with new users and balancing with existing users?
I've got.
Oh, go on.
Sorry.
The other day was about to say something.
I just thought you can say, so yeah, it's going to be a real issue because we have this new community, and a lot of us that have been in the HPC for a long time aren't from that background. So, for example, resource estimation will be a huge. Someone from fluid dynamics or a very traditional area comes up with a resource estimate. I can probably go through and about so many atoms, so much per time step, so many time steps. I can sort of add it up, and that looks reasonable. They've thought about it. But the few times I've seen resource estimations from people doing AI learning, I couldn't tell you within an order of magnitude if it was sensible or not. I don't know where to start. So I think there is the difficulty is that the current knowledge base of the people running the HPC systems is so different from the new batch of users. That's the challenge, I think.
So does that mean changing your team, bringing new people into your team,
Yes.
or upskilling your team?
Yes,
How do you cope with
we're
that?
actively trying to upskill people. Very keen to get people trained and learning and things. But it is difficult because we still don't have I don't have in mind a prototypical use case that I could I mean, if you're a physicist, it's heat dispersion on a 2D plate or something, some go-to example,
Yeah,
or
classic,
hydrogen
yeah.
atom or something,
Yeah.
which is if you understand that, you've got a model where you can sort of and also I think, I mean, it's the good and the bad thing about AI. A lot of people, the users, it's a bit of a black box, which is great. People can do seemingly fantastic calculations without really understanding what's going on underneath. But that's very hard for them to estimate. It's like, well, it's a 20-line Python script. It runs some magic, and so there's a much more of a disparity between the user and what they type and run and the hardware than there is, the first line of a CFD code, like here's 1,000 by 1,000 by 1,000 array of three double precision numbers. I've got a handle on that.
Yeah.
But that you're much higher level. I think it's the widening gap between user and the actual hardware is going to be the problem. You need people who understand the intermediate stages.
And are you finding users are much less aware, the new users are much less aware of what the hardware is and why it might matter?
Yes. Like what I would consider simple questions like, how much memory does it use? How much disk space does it use? That kind of thing are things which they're like, that's not something which, because it's not explicit in the, so the CFD code's explicit there, line 1, big array of stuff, here it's all under the hood, yeah.
Okay. Anybody else got a comment on that one, or should we move on to another question? Are there more questions? Okay. All right, Peter, keen to get going.
The services we can offer are limited by the resources that are available, and we can do our best to petition for more, but ultimately we have a limited amount. So as someone implementing these services, I would prefer to do a small number of things well, but is that what's best for the university and for the community? Where does that balance lie between doing a small amount of good stuff or maybe a wider range of services that are perhaps not as well implemented or looked after?
Okay. Balancing the good versus the perfect. Go on. Any views on that one?
I try to, I'm not offering services in the same way as the HPC stuff, but I trying to motivate the need to pay for this stuff, right? So I'm doing stuff for free, and I'm trying to do small things well to show that, hey, RSCs are useful. Maybe you should put an RSC on your next grant, so that there in 5 years there will be more resources available to do this sort of thing. So it's not exactly what you're asking, but it's related, right? That we don't have the resources now, and one reason is we don't have the people that are making the decisions or trying to get the funding don't always see the need to put it on grants in particular, right? That it will come from somewhere else, and I think getting stuff on grants is a more immediate way to get that resource.
So you're doing it as an education?
Yeah.
Yeah. Okay.
And explicitly, right? It's that I'm saying that this is useful. You should pay for it.
Okay. Balancing small perfect versus large number of not so good tasks.
So,
No.
Go on, Emma.
so I think one approach I've tried to take is consolidate as much as possible. So at one point we had multiple mini clusters and all sorts of places running all sorts of different things in different states. So by having one big cluster, which we tried to ensure was suitable for as many people as possible, that means we can just focus on that and then do the user bit as well, because we have got more resource and time. And it's the same with storage, it's the same with some of data safe haven's always been a thing, but it's a similar thing with cloud as well. I'm trying to find ways to say this is the recommended, or this is the approach where we can support you. So we brought Azure Labs in, for example, in some courses in York. And if someone comes to ask us now, we want to have a course in the cloud, we'll say, right, well, we can support you by doing with Azure Labs, we can help you to do that. If you want to go and do something else, then we might be able to help you a little bit, but chances are we won't. We just won't have the time or resource. Now, if you do want the time and resource, I'm happy to work with you to write lots of business cases, which is what I do lots of these days. And we can try and bring someone in and try and petition sort of to have extra roles created, and I'm happy to do that. We've been successful in the past doing that. But I think we have to say, this is where we put our flag, this is where we put our flag. If you want something slightly different, then that's going to, either cost you yourself your grant time, money, or we have to start looking at alternative sources of funding.
So centralisation and kind of commonalisation of doing these things.
But the idea is that it frees up time to do all the weird stuff now. We've got, I mean, Azure Labs wouldn't have happened if we hadn't centralised some bits, because they didn't have time to do that. So that's the idea. I know everyone thinks, oh, centralisation, but that was the whole thinking behind, well, one of my plans behind that, to allow people to have time to do the experimentation and trying of things, and we get new services out of that.
Kirsty, anything in your world? Do you want to add on to that?
No, I'm very much sort of echoing that, you know, what Emma was just sort of talking about, and I don't know whether that's very much a York approach or whether that's happening in other institutions, but trying to kind of offer particular things, offer them well, and offer them at service levels so that you have a bit of time and space to then explore and kind of support where it doesn't sort of fall into the run-of-the-mill or the usual things, and then kind of work out whether that leads to something new that you need to add into the mix, or whether it's a kind of one-off, but very much, yeah, core things that you do really well that you offer to everyone that meet the needs of a good majority of people, and then exploring where the exceptions are and how you can support those.
Okay, thank you.
I just think it's going to get very difficult going forward, because we took the same approach. We took a rationalization. This from the software side. We're going to support, you know, these standard software packages, Chromax, CPT, whatever, but we'll give you instructions to have install other stuff, and that constrains it down. But now, you know, you provide a standard package, CP2K, it's a quantum chemistry package, say, but users are no longer submitting a job which runs CPU. They say, well, I've got this AI framework which has got this Python wrapper that spawns off lots of jobs. So there's another layer there, and once the combinatorics, you know, we've narrowed it down, but it's exploding again. So it's going to be difficult, because those aren't standard. The pack you may have, right, we're going to support this, that runs. Oh, but it's, and then there's all clashes. Well, the Python loads this module and that conflicts with the thing, and it just gets. And that's something which we've seen relatively recently, and that's a whole. And you can't standardize. It's very difficult to standardize that, because everyone is currently, maybe in a few years, everyone's doing their own different thing, and that is very challenging.
It's all in flux.
Yeah.
Grania, do we have any questions from the online people? Okay, all right. Someone else got a hand up? Dave, stand up. Yep.
Seeing as I have the microphone already, given that resource usage is very important, I'm wondering why EPCC actually have to ask the users, do you not log what jobs are doing?
So, yeah, so actually, that was something I meant to say, actually. So we are being much more proactive. When the first query comes, it's easiest to ask the user. But yes, we are becoming much more proactive about monitoring things. And actually, a lot of people are getting queries now saying your I/O doesn't look particularly efficient, because now we have monitoring, and so we're proactively picking it up. But it's really you know, it's the first, someone submits a job and you're just trying to get it. Yes, you could go and look, but you know, it's almost engaging with them, you know, to get them to think about it. But yes, I mean, and also we don't have, you know, I can't go and look in a user's directory, and some things are more locked down than you might think. So it's, you know, how much disk space a user is using is not immediately. It's much easier for them to, and I'd like them to find, you know, you tell them how much you're using, and you know, these are the commands which will help you. You know, this is how you find out how much you're in the club. This is how much you can look at your job. And so we tell them how to do it, and that's useful, because then you've given them the tools in the future to do it. But you're right, there is a lot of, this logging on systems isn't as good as you might think, because, you know, HPC systems are slightly cobbled together. You know, I mean, Linux, we're using an operating system we found lying around on the internet. You know, Linux was not designed for HPC, it's just, you know, just the flavour of the day for Unix. So a lot of the things you'd want aren't. But yes, we do have access to that. But asking the user and actually giving them, tell them this is how you find, come back and tell me, is actually probably more productive in the long term as well.
Okay, thank you. We're heading towards lunchtime. Has anybody got a last question or comment they're willing to make? Nothing online? No. One last question here.
Thank you. So my question is very much related to this findable, accessible, and interoperable, and it could apply to data as well as system. And I wondered, do we have any best practices that the panel would like to suggest to the rest of the community? What needs to be done so that data is accessible, interoperable, but as well as the systems? Because we are just thinking about producing lots and lots of data without knowing, like, is it discoverable? So is this something?
That sounds like maybe one for Kirsty to start with.
Yes, and I suppose that is very much us thinking, you know, about our research data management planning, making sure that we're sort of thinking about FAIR principles and kind of building that in. And I think it is very much, if you start from the outset with that mindset and then kind of work through, then you can kind of make sure that you embed that and that happens, but it has to come quite early on. It's quite hard to retrofit and look at things after the fact and once you're too far down the line. And again, with software, that's got particular challenges. I'm sure some of the other panel will pick up on that one. But yeah, it's having that mindset and that approach and thinking about it from the start, being really clear what data is shareable and reusable, and again, it's that metadata piece. How do you make it findable? You have to think about how you describe it and how others will find it, and build those things in from the start and have that mindset at the beginning. That's, I think, the core thing to being successful in that particular area.
So is that a matter of user education or PI education when they're doing the grant writing?
Yes, I think if we can get more people to be aware of it, I think people who've been working in the space for a while are usually aware of a lot of the principles and how to do these things, or at least have come across them and are starting to think about it. But yeah, more education, case studies and examples as well as to where that's gone really well and how you can do it to make it seem it is doable, but it just requires a different mindset. So it's highlighting to people how they can do it and how they can be successful.
Okay. Anybody else want to chip in a thought on that one?
Yeah, I think there's, absolutely everything that Kirsty just said. There are some like generic things that everybody can do that can think about, and then there's also like domain specific things that are, how do you make it fair in your community? There's things that, you need to think about really early on, like the reusable part. You need to think about what is going to happen to the data afterwards. How, what license do I want to release this under, like for data and software? That's really important to think about from the offset, rather than surprising my PIs at the minute of like, actually you're going to want to let other people use this data somehow. And then there's other things again that are like really specific, like interoperability. So that means what are the, like, using common file formats for your community, and that's going to look different depending on exactly what you're doing, and that's a big part of it. So there are really generic things that apply to everybody, and then really specific things that you probably need to have a lot more community involvement in that. Because again, I could go on for ages about like file formats. Using what the community uses, even if it isn't the best choice, because that's what people are more familiar with. And that also applies to things like the programming language you use for your software when it comes to software, right? In biology, you probably want to use R because everybody uses R. In physics, you probably want to use Python because everybody uses Python. Nobody uses Rust, even though it's got it's got advantages and disadvantages. But if you start writing in Rust or Haskell, then very few people in your community are likely to be able to pick it up. So there's, again, those choices depending on the community.
So is there a role for RSEs when you're interacting with user codes to be saying to the PIs or people running these codes, we can modify your code and change the file formats to make them more interoperable? Is there a responsibility on the RSEs in the room to do something to help the RDMs by making the data more interoperable, by changing the codes under the hood to make them more interoperable?
Well, I can give an example of benefit of that. We're working with a code at the moment, we're just porting it, and we just want to have it's a CFD code, it's not our code, but is it doing something? It seemed to be working, but it wasn't exactly numerically similar, but is it doing anything even sensible? Is it look, because we've got a reference thing, and it was writing a particular file format, which we didn't have access to the visualizer, but my colleague said, oh, well, there's just a switch in the data file, you can do it to this, and I can look at in PowerView. So in 5 minutes, we turned that, we looked at it, and we found there was an issue, and then we got back to the PI and they solved it. But that had, them, whoever decided that they would have 2 or 3 different output formats, that wasn't their preferred one, but they put in these other ones, saved, us, and then them later on, weeks of we could say very quickly, that looks like a problem, oh yeah, okay, I know what it is, they fixed it. Whereas if we hadn't been able to do that, we'd have been like, oh, I have to install this visualizer, I don't know what it is, how it works. So it is, that flexibility is incredibly useful downstream.
Okay. Well, I'm aware we have overrun and lunch is calling, so I'd like to thank all our panellists and Kirsty online as well. Thank you.